Hello everybody, I'm Alexey Khrabrov, the organizer of SF Scala, and here we are at Nitro with a very interesting meetup. We have two talks today. One is from Spotify on SIO, which is a new API for Scala on the Google Cloud, and we have Neville Li here with us. He is the software engineer at Spotify working on data infrastructure for machine learning.
Yeah.
Welcome, Neville.
Great to be here.
It's good to have you again. You spoke at the last year Scala by the Bay Big Data Scala conference, which was a really cool talk. So maybe you can start by just like telling us what you do at Spotify and what happened recently, why Google Cloud, and what's going on.
Okay, so I've been working at Spotify for 4.5 years now. Mostly, right now I work with the music recommendation team, and that's the team that built Discover Weekly, radio stations, all sorts of music recommendation and related features. I mostly work on infrastructure tools for doing machine learning, like Scouting, Spark, and we use a lot of Scala, of course. And over the past year and a half, we are investigating moving to cloud for many different reasons: cost, operation experience, and all sorts of different reasons. Google Cloud is very attractive because they have 10 or more than 10 years of experience building big data infrastructure. Like one of the killer app is BigQuery. Also, they invented Bigtable and among other things. So those are the interesting things that we want to investigate. And it turns out they work really well for us. And they also have this new framework called Dataflow, which is based on Google's first paper called Millwheel 2 years ago. And then last year was a paper called Dataflow, basically describing this unified model for doing both batch and streaming in the same application. And they released the Java SDK, and of course we wanted to have a Scala API, so I hacked around it and then built something.
All right, so it's super exciting. So, I mean, we heard the names, but don't really know much about it. So, like, why is it useful for a company like Spotify to do Dataflow? What are the typical use cases?
Well, first off, Dataflow can run on GCP. It's a hosted managed service, which means you don't have to set up your own Hadoop cluster or Spark cluster. You just run the job from your local command line and then make requests to the Google Cloud service, and then allocates resources, creates new VMs, run your job. It handles like auto scaling and scales up and down. It also integrates with all sorts of Google data products, like it can read and write BigQuery, Bigtable, and GCS. So these are the very nice, interesting features for us. Of course, BigQuery is really fast and highly scalable. To be able to do a lot of, in this sense, it's very similar to what people are doing in Spark, like doing Spark SQL inside Scala code for your typical ETL slice and dice tasks, and then use Scala to do your like custom machine learning functions. So you can have best of both worlds inside the same application.
Do you get a machine learning library, or do you have to do your own?
Right now, the API is more closer to Spark core, like the standard RDD API. So not much machine learning, but that historically has not been a problem for us because we mostly use our own custom algorithm, so we have to write from scratch anyway. I mean, it's nice that Spark has all the ML libraries that, I mean, it took years of work to build all these different libraries, but we use a few like homebrew algorithms, so that's not a problem for us. Well, Google is also working on TensorFlow, which they open sourced like a while ago, and they're working on a cloud version of that.
Yeah, we just seen mentions today.
Yeah,
like
it will be integrated into Dataflow in the future. So, I mean, basically, you have machine learning capability inside Dataflow.
So, you guys, before moving to Google, were you on-prem? So you had your own hardware?
We had a few pieces on AWS. We started Hadoop cluster on-prem, which is basically a rack of servers in some office, and then we moved to EMR, and it was too slow. That lasted like a couple of years, and then we moved to our own on-prem Hadoop cluster. Right now, as of today, it's maybe 2,300 machines, the largest in Europe. We also, up before the Google Cloud migration, we have all our service infrastructure in on-prem.
Okay, yeah, I think I met your Hadoop guys at Strata last year. Like
Yeah.
they're based in Sweden,
Yeah.
right? And so the cluster is actually
In Europe.
in Europe. Interesting, interesting. And so you're gonna basically like, is the plan to replace that with Google Cloud? And
Yeah, but
move the jobs?
also because Google has many data centers, we are storing our data in Europe as well.
Right.
There are some legal reasons for that. I
Right.
I won't go into details,
Right.
but
I mean, there is a
reasons,
law
yeah.
like you need to keep customer
Yeah,
data
exactly,
for your
yeah.
European customers.
Yeah, for European
Europe.
customers, yes.
Yes. So I'm just kind of, I wonder if you can elaborate because folks maybe not, they don't know what BigQuery is, right? Like what, so like, you know, for people who are familiar with Spark, right? Like what is the typical use case? Like if you can give a hypothetical example, what is a data set like? What kind of query would you use, you know, for, you know, in BigQuery for, right?
Okay.
And how you would pump data? Can we like outline in very general, like what's happening?
So, I mean, at the beginning of big data, there's MapReduce, and then people introduced SQL engines, query engines on top of Hadoop, which translates to MapReduce engines like Hive.
Yep.
But most of them still like performs in a very old school MapReduce fashion, which reads all the data like row by row. It's inefficient and doesn't have any the indexes or advanced data structure that traditional SQL databases have.
Yes.
BigQuery has introduced columnar storage. It's you can read that from the Dremel paper like a couple of years ago, and basically storing data in a different format with a lot of tricks to do like compression and look indexes, lookup. So that enables SQL to run like 10 or 100 times faster than your average big data SQL engine. And also BigQuery has its own hardware infrastructure, so you don't have to set up a Hadoop cluster and you manage your own hardware and software stack. So that's a huge advantage over the traditional big data SQL and big data solutions.
Yes.
Yeah.
But I mean, I'm just curious, like given the kind of data, can you give an example of an actual query, if you can?
Well, I mean, today at the demo, the BigQuery, Google BigQuery lead was demoing, basically performing like petabytes of SQL scans through petabytes of data in a couple of minutes. So that's a huge speed benefit.
Okay.
Yeah.
Okay. And so I remember you were doing Avro and Parquet yourself.
Yeah.
Right. So obviously this is the same set of approaches, right? There's columnar storage and there's compression. So when you do this in Google Cloud, how do these skills translate? Like, they give this to you, essentially implemented on their own platform?
Basically, Parquet was inspired by the Dremel paper. It basically implements the same thing like as columnar storage on Hadoop. But Parquet is a pretty low-level API, so you still rely on the higher-level libraries to leverage Parquet. In our case, we used to do scouting Avro on Parquet, which means the programmer, the users, will have to code in a Parquet API, which is kind of tedious and not very nice. I mean, there's also Spark SQL, which is very close to what BigQuery does. Basically, you write SQL code that translates to Parquet API that does the slice and dice under the hood.
Yes.
The downside of Spark, of course, is you have to manage your own cluster, and the cluster size determines your throughput and scalability. And Google obviously has put like years of work into BigQuery so that they typically can run like thousands of workers in parallel and process petabytes of data. In practice, we haven't scaled Spark to that size yet. Yeah.
So what's going to happen to your Spark workflow? So they're going to be replaced by the Google?
We're still going to have, there are certain things that Spark offers that's not available in any other options, tools, like interactive mode, or the MLlib and the GraphX algorithms. So I see Spark has hits a sweet spot of doing medium-sized in-memory data, like interactive data modeling, exploration. So for data scientists like developing new algorithms, it's a hugely useful tool.
Yeah.
Yeah.
Like I think interactive prompt is really important for Scala developers, right? Because we are used to that, right? Like we want to have it. Essentially, like Spark is to me, it's basically a REPL backed by cluster, right? Like as opposed to your Mac.
And architecture-wise, it's also very different. Spark has a master node, and the master node drives the workers. I mean, if you compare to like scouting and and data flow, they are both massless. Basically, you have the job execution graph is determined like statically.
Mm-hmm,
It has to be determined before submitting the job. So you can do the interactive kind of processing like in Spark.
Okay.
Yeah.
And so, obviously, you did the Scala API. So, what is the kind of Scala adoption at Spotify? Who are the kind of people you see as using this Scala API? How do you see kind of this knowledge spread through the company?
Right now, Spotify, a little history. Spotify used to be a mostly Python shop, and then we moved to mostly Java because we have a lot of Java expertise from ex-Oracle engineers, etc. But Scala is really picking up as a data processing language. Most of the ML people are using Scala, Scouting, and Spark.
Okay.
A lot of the average data reporting engineers, engineers doing ETL, simple pipelines, they are also picking up these tools. And also, for this reason, having a data flow API in Scala offers a really easy transition for those people. As I will demo a bit later, the data flow, the SHIO API, it looks probably 80% identical to Spark.
Oh, interesting.
Yeah.
So you call it SCIO?
Yeah.
SCIO. Cool.
Yeah.
It's like Italian spelling.
Yeah. Well, the name was suggested by an Italian guy.
Oh, interesting.
Yeah.
SCIO. That's awesome.
Yeah.
Cool. So that's very exciting, actually.
Yeah.
Then since you mentioned ETL, I got to ask you. We have this kind of semi-joking website called noetl.org, right? And so I think the idea, like if you look what happens in Spark data flows and Kafka, you don't really have ETL because you type the objects at the inception level of the API, and they're flowing through the system. So you kind of never hope to extract them, right? They're just transformed.
Yeah.
So do you see the same flow happening in Google Cloud?
Yes, I mean that's exactly the point of data flow. If you watch live streaming, I think you can watch it live tomorrow. We'll have a talk. It's by Igor, this Spotify engineer, and me. We share the same session, but he will cover the streaming and ETL sort of part of data flow, where we use PubSub, which is Google's answer to Kafka, basically, and data flow to process or aggregate log data in real time. So, yeah, I mean, in a sense, data flow can answer some of the ETL and log collection.
Nice. So that's like another way to get rid of ETL, replace it by flow.
Yeah.
Awesome. So thank you so much. We're looking forward to your talk. And since you mentioned BigQuery, one thing I'd like to mention as well is that we have this conference called Data by the Bay in May. We'll have one of the senior engineers from BigQuery team in Seattle come in and explain how this works.
Awesome.
I think it's very exciting that we have now this in Scala community, right? Because we through your API, we're getting like all this goodness from Google. So what can we do right now if we're not at Spotify? Like you're open sourced the SHIO. Like how can we play? Like should I get a Google Cloud account? Can I start playing immediately to see what I can do?
Well, the nice thing about the data flow SDK is, of course, by default they run on Google Cloud, but it also has a local runner. It can even run on Spark or Flink. Those are work in progress, but it's possible. So you can totally run those on a laptop without even paying for a Google account. And Google, as they mentioned today, they have public data sets on BigQuery, which are free to query. So that's another way to try it out for free.
All right.
So they have like public domain data from non-profit agencies or whatever. Yeah, so you can try out.
Cool. So as soon as we learn about SHIO, we're going to play with this on Google. This is fantastic.
Yeah.
Awesome.
Good.
Thanks, Neville.
Awesome. Thanks.
Appreciate it.